One more example of converting a fraction to a decimal. Let's convert negative 2/3 to a decimal. To convert negative 2/3 to a decimal, we know that the number is a negative number, but in our division it's easier to keep the negative out of the picture, and we'll simply say that negative 2/3 will equal a negative number when we get through, but for the moment we will not put the negative into the problem because it's confusing. 3 will not divide 2, so we'll put down the decimal point, affix 0. Let's place the decimal in our answer. 3 divides 2, giving 0. 0 times 3 is 0. Subtract and we get 2. Bring down the next digit, 0. 3 divides 20 6 times. 6 times 3 is 18. Subtract, we get 2. Affix another 0. Bring it down. 3 divides 20, giving us 6. 6 times 3 is 18. You see what's happening. Subtract, we get 2. This is going to continue in the same fashion over and over and over again. You notice we keep getting 2 for the remainder. Affixing the next 0 and bringing it down, we'll have 20 yet again. And so we keep dividing 3 into 20, 3 into 20, 3 into 20 over and over again. Let's do one more just to illustrate this. 6 times 3 is 18. Still the remainder is 2. It's going to continue the same way forever and ever and ever. And so we can write our answer, negative 2/3, as negative 0.666, enough sixes so we can tell what's coming next, and then put the 3 dots, which are red, and so on in the same fashion. Or we can write negative 2/3 as the negative 0 point, and then a notation that means this pattern continues forever is to write the 6 with a bar over it. This means exactly the same thing as the 0.6666 and so on. So negative 0.6 with a bar over it means the repeating decimal 0.66666 and so on. Now I have some exercises for you to do. Copy the problems down, stop the tape, work the problems, and then turn the tape back on to check your answers. We've got 2 groups of problems. First is to place on a number line negative 6, 12/5, and negative 1 1/2. The next group of problems is to convert to decimal form. To convert to decimal form, 2 fractions, negative 23/8 and 8/15. Copy these down, stop the tape, work the problems, and then start the tape. Here are our answers. We're to place on a number line negative 6, 12/5, which is 2 2/5, and negative 1 1/2. The decimal forms of the fractions I gave you are negative 2 and 875 thousandths, 0.53333 forever, the 3 repeating, indicated by the bar. Now that we're familiar with rational numbers, let's work on the 2 things that are in our objectives. The absolute value first. The absolute value of a number. The absolute value of a number is its distance from 0 on the number line. The absolute value of a number is its distance from 0 on the number line. If I ask you how far it is to Greensboro, you might tell me 20 miles. If I ask you how far it is to Martinsville, you might tell me maybe 25 miles. In neither case did you use a negative number, even though one is going south, the other is going north. They're in opposite directions. When we measure distances, we use positive numbers. If I ask you how far it is from your house to your house, then the answer must be 0. 0, recall, is neither positive nor negative. 0 is neutral. An absolute value, therefore, either is positive or, in the special case of 0, is 0 itself. Let's use a number line and find the absolute value of 4 examples. The symbol for absolute value is vertical bars on either side of the number. So this asks us to find the absolute value of 3. The absolute value of 3 is its distance from 0 on the number line. Here's 0, here's 3. From 0 to 3 is 1, 2, 3 spaces. Absolute value of 3 is 3. This asks for the absolute value of negative 4. The absolute value of negative 4 is its distance from 0 on the number line. Here's 0, here's negative 4. The distance from 0 to negative 4 is 1, 2, 3, 4 spaces. Distance is 4. So the absolute value of negative 4 is 4. The absolute value of negative 1 and 4/5. Here's negative 1. Negative 1 and 4/5 would be closer to 2, right about here. And the distance from 0 at negative 1 and 4/5 is 1 and 4/5 units. The absolute value of negative 1 and 4/5 is 1 and 4/5. And then our special case, the absolute value of 0, the distance from 0 to 0 on the number line is 0. So notice that in each case, the absolute value came out to be a positive number or 0 itself in the special case. Now let's define the opposite of a number. The opposite of a number n is found the same distance from 0, but on the opposite side of 0. The opposite of a number n is found the same distance from 0, but on the opposite side of 0. For instance, the opposite of 2 is negative 2. The opposite of 2 is negative 2. It's the same distance from 0, but on the opposite side of 0. 2 and negative 2 are on the opposite sides of 0. Now, if we write down the opposite of 2 every time we are asked to find the opposite of a number, that means that we've got a lot of writing to do. So we've got to improve our notation. One more illustration. The opposite of negative 4/3 is 4/3. Negative 4/3 would be negative 1 1/3. That's on the left side of 0. On the other side is positive 4/3, positive 1 1/3. So the opposite of negative 4/3 is positive 4/3. The symbol for opposite is a minus sign. The minus sign before the n expression, the number, means the opposite of n. I have written parentheses around the n. They are optional, but they're helpful to let you see what the symbolism is. The minus sign preceding the number means the opposite of the number. So if we want to write the 2 problems I've given you, 2 examples, we'd say The opposite of the number 2 is -2. And the opposite of the number -4/3 is 4/3.